Reading graphs of functions. All right. So if we think back to function notation, with function notation, we saw things like f of x is equal to x cubed minus 5x plus 2, something like that. Or, g of z is equal to z to the 5th plus 7, where this over here was our input variable, and that meant that whatever we replaced x or z in this case with, we replaced over here in the function. All of these functions that are represented in function notation also have corresponding graphs. And the way those corresponding graphs are made is by taking a statement like f of a, where a is your x value, is equal to b. F of a is equal to b, and plotting it as a point on the graph where a is the x value and b is the y value. So if f of a is equal to b, that means that a comma b is a point on the graph. And that's a really important fact. If f of a is equal to b, then we have created the point a comma b for the graph of f. And that's how we form the graph of f, is by plugging in different x values, getting y values out, forming points, plotting them. What's really, really important, though, is that the output of a function, right? This is us telling us to input a into function f. This is the output. B is the output. The y value is the output of a function. The output of a function is the y value of a coordinate point. i.e., f of x is equal to y. So if I said f of 7 is equal to 2, this means that the y value when x is equal to 7 is 2. i.e., the point 7 comma 2 is on the graph of f. All right, let's do some stuff with that. For the function below, find f of 2 and determine the point on the graph. So we're plugging 2 into this function, x squared plus 3x minus 5. We have 2 squared plus 3 times 2 minus 5. Woo. 2 squared is 4 plus 6 minus 5. That gives me 5. So f of 2 is 5. That was part of the question, right? What is f of 2? Well, f of 2 is 5. The other part of that question is answering what is the point on the graph? And the point on the graph The x value is the input, so 2. The output is the y value, 5. So the point 2, 5 is on the graph of f. Not so bad, right? Not so bad. Let's work with it a little more. Consider the function below. F of x is equal to 4x squared minus x minus 3 is the point -2, 15 on the graph of f. Right. So I'm asking myself, when I plug in -2 to this function, is the output 15? So I'm plugging in -2 to my function. 4 times -2 squared minus -2 minus 3. This will be 4 times 4, which is 16, plus 2 minus 3. That's 15. So f of -2 is 15, which means that the point -2, 15 is on the graph of f. If instead we had gotten a different number, like 0 or 7 or -8, if we'd gotten a different number besides 15, then that would -2, 15 wouldn't be a point on the graph of f. Remember, functions are created in such a way that every x value only has one y value. So if we find out that the y value of -2 isn't 15, then the point -2, 15 cannot be on the graph. If x is equal to 2, what is f of x and what is the point on the graph? So plugging in x equals 2 to this function, right? The coordinate point we know is going to have value 2, x value 2. We just need to find the y value. So f of 2 is equal to 4 times 2 squared minus 2 minus 3. 2 squared is 4. 4 times 4 is 16. So 16 minus 5, that's going to be 11. F of 2 is 11, which means the point 2, 11 is on the graph of f. Did this on YouTube, please tell me that I edited this in the future. We're going to change some values here because this f of x equals 3 doesn't work out. We're going to make this f of x equals -3, and this is going to work a lot better. All right, make this change on your notes. F of x equals -3, not f of x equals 3. This problem down here is different than the previous problem. The previous problem, we had x equals 2, and we're asked what is f of x. Here, we're told f of x is equal to -3. What is x? So this is different. We're told the y value. We want to know what x values have a y value of 3. So if we take our original function, so f of x is equal to 4x squared minus x minus 3, and we replace the f of x with negative 3, then we can solve for x. So we have negative 3 is equal to 4x squared minus x minus 3. This is a quadratic equation. We need to move everything to one side, factor it, and solve. So I am adding 3 to both sides to make one side 0. 0 is equal to 4x squared minus x. Those negative 3 plus 3's cancel. I'm going to move the equals 0 to the other side just because I like the way it looks better. Factoring out an x, I have x times 4x minus 1 equal to 0. Using the zero product property, we have x is equal to 0. We have 4x minus 1 is equal to 0. If you solve, you'll get x is equal to 1/4. So there are two x values that have a y value of negative 3. So we have 0, negative 3, and we have 1/4, comma, negative 3. So once again, the process here, we are given the y value. We are given f of x is equal to negative 3. So we replaced f of x with negative 3. That gave us a quadratic equation. We moved everything to one side so that one side was 0, which allows us to factor and set each factor equal to 0 and solve for x. Once we had two different x values, we're able to take those x values and plug them in as, for the points. So negative 3 was the y value. It was given to us. We solved for the x values. All right. Some more examples. The graph of a function h is shown below. Find one value of x for which h of x is equal to 1, and find h of 0. There's two different things happening here. So one value of x for which h of x is equal to 1. Let's start with that. If h of x is equal to 1, that means that the y value is 1. The y value is always the output of a function. So y is equal to 1. This is asking you to find the x value of a coordinate point that has y value 1. So we have like a coordinate point here. We know the y value is 1. We're looking for this x value here. Looking back at my graph, looking for the y value 1, right? This is y equals 1 right here. There are two places on the graph where the y value is 1. The first point is negative 1, 1. And the second point is 2, 1. So we have two answers to this. It asks for only one. I'm just going to go ahead and get both. So h of x is equal to negative 1 when x equals negative 1 or 2. When the x value is negative 1 or 2. I.e., h of negative 1 is equal to 1, and h of 2 is equal to 1. I'm able to determine that by these points on this graph. The fact the point negative 1, 1 exists on the graph in the first place, that tells me f of negative 1 is equal to 1. That's just the direct translation of that point. So h of x is equal to negative 1 when x is equal to negative 1 or 2, i.e. h of negative 1 is equal to 1, and h of 2 is equal to 1. The next part of this problem says to find h of 0. H of 0, you have your x value, right? This is saying that the x value is 0. So the coordinate point we're looking for is 0, comma something. H of 0 itself is the y value when x is 0. The y value when x is equal to 0. So x is equal to 0 right down here. This is the point 0, negative 3. Direct translation of 0, negative 3 being a coordinate point is that h of 0 is equal to negative 3. So literally all you're doing to find h of 0 is just going to 0 on the x-axis and finding the y value of that point. We'll do it one more time, right down here. First problem says to find f of 2. F of 2 is the y value when x equals 2. Right? X equals 2, so that's this point right here. This is the point 2, comma 1. The y value is 1. That means that f of 2 is 1. For the second portion of it, find one x value, find one value of x for which f of x is equal to negative 1. F of x equals negative 1 means the y value is negative 1, and we want to find x values. Oop. So we're looking to find x values where the y value is negative 1. Negative 1 on the y-axis is right here. There's only one point where that happens. This is the point 0, negative 1. So f of x is equal to negative 1 when x is 0. Okay. This point itself directly translates to the statement f of 0 is equal to negative 1. It's the direct translation of that statement. Okay. All right, just a few more problems here. We're going to do a little bit of interpreting. So we have a graph here. We're going to be answering some questions. So this says, for which values is f of x greater than 0? Translations. So many translations. F of x, that's y values. For which x values, it really should be x values, for which x values is f of x greater than 0? For which x values are the y values greater than 0? Y equals 0 is this line right here. So y values being greater than 0 are going to be anytime the graph is up here. If the graph is above the y-axis, the x-axis, if the graph is above the x-axis, the y values will be positive. So greater than 0 would just be positive. When are the y values positive? And we're looking at the corresponding x values. So on this portion of the graph right here, the y values are positive. And on this portion here, the y values are positive. We have to be a little bit careful here. Hopefully you watched my interval notation video, so I don't need to re-explain interval notation. If you haven't watched it, please go watch it now, or you may be kind of confused about what we're going to talk about. We want to know where the y values are strictly greater than 0, not equal to 0. So we have two different intervals here. We know one of those intervals starts at the x value -4, and it goes up until 0. We just need to decide whether to use brackets or parentheses on this interval. At -4 itself, this is f of -4 is equal to 2. -4 has a y value that is positive, so we will include -4. But at 0, the y value is 0 itself. So f of 0 is equal to 0. 0 is not greater than 0. So we exclude 0. This interval over here, because the graph is 0 at x equals 4, we don't include 4. So use a parenthesis. And here, we don't include 6 because the y value at 6 is 0. So this is saying directly that between x values -4 and 0, between these x values, if you plug in any number between -4 and 0, including -4 but excluding 0, that you will get a y value that is positive. You'll get a y value that's greater than 0. Anywhere between 4 and 6, except for 4 and 6 themselves. If you plug in any number between them, the y value will be positive. F of -2, find f of -2. This is going to be the y value when x is equal to 2. So, this is the point, -2, comma, something. That something is f of -2. So I'm going to my graph. I'm going to -2. Oh, look, there's that point, -2, comma 1. -2, comma 1 is on the graph, which means that f of -2 is equal to 1. That's how we rewrite a coordinate point. Find all x such that f of x is equal to 3. This is the y value. This is the output. This is the output. So the y values are 3. Find all x values such that the y value is 3. So 3, the y value 3, right? 3 on the y-axis is like here-ish. So we're looking for where does this graph hit this line? It only hits in one place. It's at this point right here, 5, comma 3. So the only x value that gives the y value 3 is 5. And then finally, is f of 3 positive or negative? F of 3. So f of 3 itself is the y value. So we're going to look for x equals 3, right? This is going to be the point 3, comma, I don't know, some number. It's not listed on the graph. We can't figure it out. But what we do know is that this value is f of 3. The y value is f of 3. That y value is going to be negative because it's below the x-axis. It like looks like it's around -1, right? And -1 is a negative number. So f of 3, which is again the y value when x is equal to 3, is negative. All right. Ugh. I'm going to go through these remainder of examples quickly. This video has already turned far too long. So find all x such that f of x is equal to 0, where the y value is 0. The y value is 0 here at the point -2, comma 0, 3, comma 0 right here, and this point right here, which is 5, comma 0. All of those have y values of 0, which is what f of x equals 0 is saying. So those x values are -2, 3, and 5. Those are the x values where the y value is 0. Is f of -2/3 positive or negative? -2/3 is like here-ish, right? Somewhere in this range. And that means that the point associated with it is somewhere up here. This is the x value -2/3 and some y value. This is asking, is that y value a positive number or a negative number? That y value is a positive number because y values are positive up here. So this is positive. The y value when x is equal to -2/3 is positive. Find f of 0. This is a different question than the first one. This isn't saying find the x such that f of x is equal to 0. This is saying find f of 0. F of 0 is a y value. F of 0 is a y value. This is y is equal to 0. So we have a coordinate point, not y equals 0. This is x. This is x is equal to 0. The output itself, f of 0, is a y value. Whatever number goes here is f of 0. If we look right here, this is where x is equal to 0. This is the point 0, comma 3. F of 0 is equal to 3. Finally, is f of -3 equal to -4? Translation, is -3, comma -4 on the graph? Let's look. There's this point right here. This is an open circle. That's an open circle, which means that point doesn't exist. -3, -4 almost exists, but it doesn't because it's an open circle. So no is the answer. F of -3 is not equal to -4 because that point doesn't exist on the graph. All right. So this last one is a lot more than than I think I want to do for this video at this point. I'm going to go ahead and put the answers down. I'm going to pause it, put the answers down, and talk about the answers. Work through this if you would like to work through it, but give me a sec. All right. Oops, I forgot to box this one. Quick explanation of these answers, and if you'd like a further explanation, feel free to email me. Find f of 0 and f of 2. These are asking for the y values. The y value when x is equal to 0 is -6. That's the y value when x is equal to 0. This is the point 0, -6. The y value when x is equal to 2. This is the point 2, -7. So the y value is -7. F of 2 is -7. Evaluate f at 4. This directly translates to f of 4. So evaluate f at 4 is the statement, what is f of 4? F of 4, that means the x value is 4. F of 4, right here. Oop, did I get the wrong value there? I did. That's -1. F of 4 is -1 because the point for -1 is on the graph. Is f of -3 positive or negative? So this is going to x value -3. Right. X value -3 is right here. And that's this point here. I don't know exactly what the y value is. It's asking, is the y value positive or negative though? Okay, this is the point -3 comma something. It doesn't matter what. This is going to be a negative value, right? It's between -5 and -4. It's going to be a negative value. So f of -3 is negative. For what values of x is f of x equal to 0? This is saying y value. When is the y value 0? That's going to happen at 2 points, once right here, once right here. That's at x equals -9 and 7. Coincidentally, f of x equals 0 is the same statement as x is an as being an x-intercept. This is an x-intercept. If the y value is 0, it's an x-intercept. So these values are the same. What are the y-intercepts of f? The y-intercepts down here at -6. For what values, for what x values is f of x equal to -4? So let me go ahead and just highlight -4. So it says f of x equals -4, which means that the y value is -4. That's going to happen right here, right here, right here. Did I miss one? And again, well, let me just move this guy over. -7 should be on here too. I just missed that when I was going through it. -7, -4, 3. For what values of x is f of x less than -4? So when are the y values less than -4? Well, here we drew -4. During this section right here, the y values are less than -4. Everywhere else, the y values are greater than -4. So that's going to start at x value -4, and it goes until x value 3. Because it was strict, it said strictly less than -4, we don't include -4 or 3. Because at -3, or at -4, the y value is -4, so we wouldn't include it. For what values of x is f of x greater than 0? Greater than 0, that means those y values are above the x-axis. So that's going to be these two portions right here. For the endpoints, we're not including -10 because -10 has an open circle, so that point's not real. -9 is, at -9, the y value is 0. So f of -9 is 0, and this is an exclusive, so it doesn't have an underline underneath it. So we don't include -9. We don't include 7 for the same reason. We do include 8 because f of 8 is 3, which is greater than 0. F of 8 is 3, which is greater than 0, so we use a bracket to include it. All right, this video went on far too long, but that is analyzing graphs, or reading graphs of functions. I will see you in another video. If you have questions, send me an email. All right, bye.